Hello, it's Duncan. Last week, Lukas Eder, the brains behind Juke, helped us understand the basics of his SQL mapping library. This week, he helps me finish the job as we refactor the code from last week into an implementation of our items repository. By the end, we have versions in Juke, exposed, in memory, and on disk. Make sure you watch the end, as Lukas has some great insights into the difference in philosophy and implementation between Juke and exposed.
That's why we write tests.
That's why we write tests.
So the tests can have bugs.
So we've managed, in fact, to do that in one query. We've obviously got an issue here around what happens when we have no items in our database, right?
Mm-hmm.
It can't be that we're able to get a max of items modified, but we have no items to match it, because that's a logical impossibility. But we may have no items at all. So I'm going to write a test for that.
Yeah, if you don't have an insert, then it will fail.
Yes. So let's say, so it feels to me like, in fact, if I pull this thing into a var, right, that this is, and it needs a DSL context in order to be separated out from here. Yeah. So that DSL context is the thing that's bringing a database connection with it. Is that right?
Yeah, and it will be transactional eventually.
Splendid. Okay. So if I make that a parameter, then I figure that I can pull this out of here, but no longer becomes tied to my tests. And then I don't know, but I kind of feel like I want to pretend that that's a method on DSL context. So that would be DSL context load gives me a stock list.
Yeah, you can do that.
Feel too horrible to you?
Well, it's a matter of taste, I guess. It's just a notation, right? A.B or B and with A as an argument.
Yeah, it is one thing that I miss in every other language. It's
extension functions.
Extension functions, yeah.
Yeah.
They work so nicely. And it should be also the same thing here, right? So I should be able to say this thing is save, and that should be my stock list, which is a parameter in here, and that wants to be a parameter.
Yeah, now you do
so that's my DSL context, and then I say the same thing here. I say make that a receiver, and I take this thing and take it out of here, and they feel like production code, right? And then I can inline that, and I can say test load. And I think we had a rule, so we don't save it, we load it, and it shouldn't look like an initial stock list. It should look like a stock list whose last modified is instant epoch and has an empty list. Okay.
That's probably going to fail currently.
I hope it'll fail. Okay. But it hasn't failed in SQL, which is good for us, right?
Yeah, there's nothing wrong with the query.
Yeah. So, and it just returned an empty set. Then I'm going to say that if that was null, if last modified equals null, then this should be instant epoch, else last modified.
Well, the type's not correct. It's a pair.
So that wants to be, let's just take that away. We'll say if last modified equals null, that else last modified dot first. Run those tests. Awesome. I don't like the fact that IntelliJ is crashing every time I do that. So I wonder whether the fact that it's crashing is responsible for that. But that's a bit better, right? It's not really last modified, it's a pair of last modified, but that'll do. I think we may have everything we need to implement our interface.
You want to look into transactions as well?
Yes. So before we go on, talk to me about transactions. What delimits a transaction here?
Currently, you're in auto commit mode, which is default in JDBC. So every query commits automatically by itself.
Which actually, given that we are doing our load in one query, is probably okay for us, certainly here, right?
Yeah, I guess.
In our database version using exposed, we were a bit embarrassed because we had to go and fetch in two queries. That's here. So I had to do get last update. And so I had to make sure I was running in a single transaction there. Actually, we have no other transactions in the system. So in fact, this would be fine, but let's implement what we've got, and then we'll add transactions on the top of that, because I think that's doable. So let's get rid of that and that. And we've got our Juke test, and we've got two nice little bits of code there. So let's remind ourselves what our items looks like. So we have save a stock list and load. And so basically we've already got those now, haven't we? So let's go to, we've got Juke here. So I've got Juke tests. I'm going to write new class, and we're going to call this Juke items tests. How do you capitalize Juke in Java?
Yeah, I didn't think about this. Like you. It's almost impossible. How do you camel case or Pascal case SQL, for instance? SQL?
Yeah. I mean, the rot set in
So
with URL and URI, didn't it?
Yeah. Yeah, but they don't agree.
No.
Like the JDK, and it's always different. XML is the same thing.
I'm going to copy that and put it in here. This is my sort of template. So the contract here, it manages what should happen. Like it saves, so you see we've got returns an empty stock list for any save, but we've just written that, right? And returns the last save stock list, we've effectively written that. So this manages being the same test for all of our implementations, and it requires an implementation of items to work with. And then the individual tests themselves, so our database items tests, are responsible for resetting the DB in order it's empty between tests. So if we were to take something like this and put it into my Juke items tests, I think this is where sort of TDD goes wrong, isn't it? Because all these tests have to pass. I need to now move everything over into this abstraction that exists already. But how did we reset the database? So we had a DSL context and we did clear DB. So I'm just going to copy those and in my Juke items tests. And the test data source, I should just be able to import from that place, right? We'll share it for now. So that's our Juke version of clearing the DB. And then this wants to be our Juke items, which doesn't yet exist. And that was on the test database, which is exposed. That's not what I want. So that's on my DSL context eq. So for now, at least, I'm just going to pull that out of this test and worry about that lifecycle later.
Mm-hmm.
Because that's probably going to be a sort of singleton shared between all the tests, I guess, is normal, isn't it?
Yeah, most people when you use Spring, you just inject that.
Yeah.
Configure it or whatever.
Spring solves so many problems for us, doesn't it?
It creates new ones, but
okay, so I'm going to give myself a Juke items, and I'm going to put it in. You know what? I'm going to leave it in here for now. Okay, so I need a DSL context. Okay, and it's an items, and so we need to implement some members in transaction, so on and so on. And this thing is our transaction type. And somewhere I was cheeky and had sort of the idea of no transaction. So I can do that for now. So we've got this TX context. There you are, look, no transaction. So what I'm going to say is, until we do it, we don't need a transaction. And that means that that needs no transaction. Okay, getting there. Okay, and now our test is also doesn't have a transaction. Okay, so we just don't have any code. But that's quite all right. So let's look at Juke items and say, we don't have a transaction. So this thing just needs to return the result of running that block with the instance of no transaction. That's our sort of way of getting to how do we run transactions. IntelliJ's formatter still really doesn't understand context enough to lay things out so you can read them. But I think we've got this already, right? So we can go to our Juke tests and make this public. Well, in fact, of course, this is Kotlin, so that's just like the truth. That's still private, and we had save, and we'll make that. And ignoring the issues with our result type and whether we get errors, which I think we should for now, this thing is return success of our DSL context, save, a stock list. Okay. Results, stock list loading error, found stock. Okay. So now there's a small wrinkle here, which is that I have save return the thing that it just saved in order that you're forced to go and check the error type, basically. But that's easy enough. We can just take that out of here for now, and we can say return success of the stock list. Here we have the same sort of problem. Well, the same sort of solution, more to the point. We can say return success of our DSL context load. Okay. I'm wondering why that says it's not that. Where is that? Oh, that's interesting. Have I typed those differently? That needs to be a ow. That's more like it. Oh, okay. Cannot be cast to exposed transaction context. Okay, so I just messed up one of the things in my contract. That's no transaction. That's no transaction. Here. So that should be that we don't have a transaction type for now. See, I don't think that should compile. Okay. We're very close. We've got one working.
Precision problem?
No, so we're actually getting a last modified returns an empty stock list. So we're getting, so
we're not deleting stuff.
We're not deleting stuff, are we? No. I think what's happening is that I am running the tests in parallel. And so let's...
And because the Juke ones aren't transactional,
do that.
You can read the other transaction. And you're deleting stuff only at the beginning of a test?
Yeah.
Instead of at the end?
There we go. Oddly enough, one of the things on my list to talk to you about was how to run tests in parallel with Juke.
Yeah, well, each thread could have its own database, or you have to be very sure of your transactions. I mean, in the end, you want to test transactional code. There, you have a bug, right?
I've written test code against Amazon SimpleDB, for example, and in those cases, yes, I effectively always just used to have a table name appended with some random thing.
Yeah, so Juke has a schema mapping feature where you can map your items table to items whatever. So you can at runtime decide what the actual items table will be that Juke writes to or reads from. That would be perfect for this kind of multi-tenancy that you want to do.
So I think fantastically we are where we wanted to be, are we? Except for transactions. So the lesson we've learned is parallel tests with persistence is a problem. And I think it's a problem we solve in the rest of the code base because we set up temporary directories to save our tab separated file. So that's not an issue. At the moment, at least, the simple thing is to just not run our tests in parallel. And I'm sure there's some way of telling JUnit that I want to run these tests in parallel or not these and so on. So I will fix that all by myself. But I think we have managed to get Juke items working with the exception of transactions. And I think at the moment, certainly it is safe to not have transactions, but I will plug away myself and have a look and see whether I can work out how to do that. So we've managed to implement our contract we had with all of our other implementations, which is fantastic. We've got Juke items. Let's compare that to database items, which is the exposed version. So we'll ignore the transaction bits. We have here save, so we have 2 saves and 2 loads. And isn't it actually, it's impressive how the shape is the same, isn't it?
Yeah, it's a very simple application so far, right? So there's no magic so far.
No.
I wish I could have shown you multi-set and some more advanced stuff, but I guess the first step of refactoring, it's going to be very simple. Yes,
we have no joins, so there will be a time when Gilded Rose is such a world-class organization that So comparing these two, we're doing for each in both cases. In fact, we're saying stock list items for each, stock list for each, same thing. Insert into items. Here, though, we're saying we've got this items table insert. And I suppose to me, that's the fundamental difference, is that this DSL context gets involved and carries the database connection with it, where exposed has magicked a transaction out of thin air. Yes, that was the thing I certainly didn't like. But this items table insert into... Oh, so there's a difference here, I suppose. The items table is a type that we are calling things onto, and here we're saying insert into items. And
Well,
then
you
I
can do
suppose...
the other style as well with Juke.
Right.
You can have an items record and then add to its properties and then call insert on it.
I suppose, though, this is because you're starting from SQL, really, isn't it? You're far closer to the SQL syntax here.
Well, if you want to do SQL and I mean more advanced SQL, then we have to support the syntax as well for insert statements. I mean, you can run insert select, you can insert on duplicate key update, you can run a merge statement.
Yes.
But for the really simple CRUD, so for this particular example, we could have mimicked the exposed syntax by just creating a new items record, setting all its properties, and then call store on it.
Right.
So in this particular case, if you're looping anyway, that would be an option.
Yes. And actually, in some ways, think that might be good for me because that feels sort of slightly more reusable. This mapping here between whatever this insert statement is and an item is a single thing. It's in one place. Whereas here we split it between here and here.
Yeah, but as I said, you can mimic that syntax as well, even with SQL. So after insert into, you can type set, and then you have the exact same mapping.
Right. Oh, brilliant. I will play with that.
Mm-hmm.
Load is where I think we have a major advantage because in the case of exposed, we're having to do things in two goes. We're having to go and get the last modified. And there's this slice which I never really understood, to be honest with you. It's not SQL. And every time I used exposed, I had to look this stuff up. Whereas a subselect, I think I mainly typed this myself, didn't I? The nice thing is that we're running this in one go. So we've got one trip to the database as opposed to two trips.
Mm-hmm.
I sort of got the impression there was some way of doing that sort of thing in exposed, but largely you're on your own, I found. If Stack Overflow doesn't answer your question, you can't go to what SQL you would have written. Whereas this way, I feel that I can at least go to SQL to the extent that I understand SQL.
Yeah, the philosophy of Juke is really, you want to write SQL and you want to, for some reason, have it embedded in your Kotlin code, maybe even dynamic, and then that's the only difference. So you should really think in terms of SQL, and you have SQL syntax in your mind, and then you write exactly that.
One thing I think they do share, so I've sort of used Hibernate and to some extent JDO in the past.
Wow,
and those things are very much sort of based on building types and having those types populated for you, as opposed to building queries and having those queries marshaled for you. And exposed and Juke both, I guess neither are ORMs, are they? They're not doing object relational mapping. What they're doing is query mapping.
Yeah, that's how people often distinguish between your things. So with an ORM, you want to have an object graph that you want to be able to persist. So the focus is also on persistence when you write, which is probably a bit more difficult if you have a complex tree of data with items and item children and maybe parent entities, and you want to move everything around. Then with SQL directly or with Juke or exposed, it's a bit harder than with an ORM. But once you query your data, it's the query complexity that needs to be modeled, and the mapping maybe. And we didn't get much into the mapping of Juke, but these kind of things work really nicely with Juke. So for instance, when you want to project really complicated nested collections, Juke can help you here in a type-safe way. So you can have arbitrary levels of nesting and fetch everything in a single query. I guess with a single table, this isn't going to be very impressive in your case. But once you have other tables, and instead of joining them, you can also decide to just nest them and get some sort of hierarchy of data in a single query. And this is going to be really nice, especially with Kotlin.
At one time I liked Hibernate, but I came back to a project. It was a Spring project. Spring. It was a Swing project, so it wasn't a natural home for Hibernate. But established that because of the ORM nature of it, this project effectively loaded the entire database into local memory.
Yeah, it's hard to tune correctly, right? So the defaults are often wrong. You either eager fetch everything and then you get too much data, or you lazy fetch everything and then you get too many queries.
Yes.
And of course you can write the queries manually, but there's always a risk of accidentally forgetting something in a query, and it's going to be fetched automatically in tons of extra queries.
I think certainly the thing that I've learned over the years is that relying on your database to offload as much work into queries as you can, bringing back only the columns that you need to answer the question you have right now is a far, far nicer way of working than bringing back everything about a table in order to answer simple questions.
Yeah, it's going to scale better.
Yeah. Lukas, thank you very much. I plan to go and look at transactions and not waste your time with that.
I think the really interesting cases where I can help again is when you have more than one table. So we can look into some advanced, we can do another session maybe. We could look at some advanced use cases. I guess it doesn't make sense with only one table right now, but
it's a nice thing about starting at the beginning.
yeah.
Is there anything else you would like to say about jOOQ or Exposed? How have you found Exposed, by the way? I'd be interested.
I mean, I don't have any opinion about it. It's just I've seen tons of these APIs come and go in the past. Exposed follows a similar model as Scala Slick, so they kind of invented their own query API. For some reason, not mimicking the SQL syntax. So I guess they wanted to make it look more like Kotlin. But in my opinion, this quickly breaks down once you want to have some advanced syntax mapping. So like, for instance, in SQL, you have lateral joins or window functions or grouping sets. And how are you going to represent that in a Kotlin style? It's almost impossible. They're going to invent new API, and these kind of APIs are really hard to learn. So is a user going to invest into this API? I don't think so. So this was the strategy with jOOQ, to not add anything that people have to learn. So there's nothing jOOQ specific except for setting up the code generator. But once you have set that up, it feels like SQL. So it feels like you're writing a store procedure, right? So it should be different. There shouldn't be any hurdle, any challenge to learning the API. So I think this is the main difference. They could have done the exact same thing, but weirdly they didn't. I don't understand why. Other than that, I mean, it's, as you said, it doesn't have too many features. I don't know why. There's no limit to how many things that should be implemented. It's just a matter of how much time you invest.
I think there is that investment, isn't there?
Yeah. And it gets really hard. I mean, it looks so simple at first, right? Select from where, but once you start adding unions and limit and all these kind of things, so limit looks really simple, but it's extremely hard to implement correctly for all dialects, right? So some dialects like MySQL and Postgres just have limit and offset, and it's very easy. But if you want to support all the dialects, you maybe have to nest your query using window functions and derive tables, and that gets really, really messy. And everyone who's tried, even including me many years ago, make the same mistake of thinking that it's it's simple, but it's really extremely complex. So this is kind of the point. There's always people who think they're going to be limited by the DSL. So the actual language, the SQL query language, is obviously even more powerful than any DSL can ever mimic, including jOOQ. So there has to be a lot of value in that. So, and this value can only be achieved by offering an extreme amount of SQL features, right? So if every time you want to have some substring function, you have to kind of shoehorn that into your query with some workaround or tweak, people are going to hate the DSL because it starts being limiting. So it should be enabling, and that means you have to invest a lot of time into features. I mean, SQL feature support. For instance, jOOQ also supports spatial features by now, and tons of vendor-specific stuff, and JSON. We didn't touch on that, or XML in the database. So jOOQ supports all of that. Because if you have the problem and you want to use the feature, you can use it with jOOQ. And I think if you want to implement a DSL, it should be as close as possible to SQL. It should be very, very big, the DSL. So it should support almost all SQL features. I personally also think it should use a code generator, because if jOOQ's users maybe have databases with thousands of tables, and there's no way you're going to handwrite those table definitions again in Kotlin, right? So you need some sort of code generation, at least as an optional feature.
Yeah.
I don't have any experience with Exposed, so I can't really be specific about it. I mean, I understand, for instance, the syntax to create an object like that, object table, is kind of compelling for simple applications. And people have done that with jOOQ as well. It's possible to do exactly this with jOOQ. Instead of generating the table, you can write it yourself using internal API at your own risk, of course. But I think you're still not going to get all of the features out of it. For instance, if you use aliasing, we didn't do that, but you can write items as, you can try it really quick. If you write items.as and then you use an alias, it has to be right after items.
Yep.
So you have to quote that in Kotlin, unfortunately.
Yes.
Yeah. But now this object, you pass a string, an alias, and you can still dereference columns from it. So if you type .id after banana, I mean after the parentheses, outside. Yeah, there. You still get all the type safety and everything, so it's really hard to see how this could be possible without code generation.
I think actually that just that idea that SQL is big and you don't want to be limited by the support of SQL in your mapping layer, I think is a very persuasive one. You either have to do the very, very minimum. So, I mean, I know people who are quite happy basically with IntelliJ's embedded SQL in strings support.
Yeah, of course. I mean, that's
because it's
sufficient
quite
for many
smart and
cases.
you can write little mappers yourself and that's all good. You are untype safe, but that's okay, largely. That's one end of it. Otherwise, you pretty much have to support all of SQL in your DSL in some sort of way. And that's a big job. That's a big job just with SQL. And it's an even bigger job when you consider that you then have to make things work across databases. So you've got those two things. How long have you been working on the project? I'm fascinated.
2009, so 14 years
Right.
now. It's
Goodness
quite
me.
old by now. So right now, Juke 3.18 supports, I think, 30 dialects, and the next version will support at least 32. I've never seen as many dialects being supported by another SQL library. It's really no one somehow no one actually goes to the end and does that, right? So the scope goes a lot of SQL language features plus a lot of SQL database products. That means the test matrix gets enormous.
Yes, I can imagine. Well, Lukas, thank you so much. People can find you on the internet at jOOQ.org.
Yes.
And follow you on Twitter, I suppose. Are you still on Twitter these days?
Yeah, until it goes down.
I have enjoyed this so much. As I say, it's been lovely to work with you. I'm sorry for taking up so much of your time. Let's hope I manage to edit this down into something that takes up slightly less of the viewer's time. But I think I'm convinced, I think Gilded Rose is going to adopt you.
Yeah, hope so. There's no turning back.
No turning back.